Welcome. This video is a demonstration of Java data structures, specifically the Fibonacci sequence. And so if you want to know more about the Fibonacci sequence, I recommend this website here. And there's certainly many websites, but it's an algorithm. It's a sequence. It's a series of numbers. Starts off, it looks like this: 0, 1, 1, 2, 3, 5. I always like to use the number 5 as a reference. 5 is 5 in the Fibonacci sequence. So if you're looking for, well, we just talked about 5, but let's say you want to know the Fibonacci number of 6, it's 8. If you want to know, you see how this goes in order: 1, 2, 3, 4, 5. This is the number line here. If you want to know 7's Fibonacci number, it's 13. And how do we get 13? 7 gets 13 from adding 5 and 8. And where does 8 get its number? 8 comes from, let me see if I could zoom in here. No, yeah, 8 comes from 5 plus 3. And where does 5 get its number? It's 3 plus 2. And 2 is 1 plus 1. Okay. This number up here, big number, 377, same thing. So every Fibonacci number along this number line here is simply the product, the sum of the immediately prior two elements. So yeah, there's all kinds of stuff, and in my Java program here, I got this class here called Fibonacci, and this is the algorithm. And it uses memoization, where it takes the Fibonacci number at each node, and it stores it in a array list. And this I think I actually have an extra import there. I could delete that. Okay, so this program uses DAO pattern. I've had a couple other projects where I use the DAO pattern, but it's a JDBC connection with Postgresql, Maven project. It's a big program. It's got almost 200 lines of code here for the main method. Uses the switch. They actually just came out with a new syntax for switch things. So in this program, it's pretty sophisticated. What it does is it takes an input, a user input. So let's say a user inputs, let's say the user inputs the number 70, right? This program will calculate the Fibonacci number of 70, and it will print out the array of all those Fibonacci values, and it will persist all the Fibonacci numbers, the whole sequence, up to, like, let's say a value of 70. It'll persist it into a Postgresql database. And in the Postgresql database, there are two tables. In one table, you have the choice of storing a Fibonacci sequence for however long you want. And the other table is good for just using this app here. It's just kind of short-term memory. And this software has all the CRUD methods: create, read, update, and delete. A lot of them, because we're controlling two different tables. You of course have your interface, these two DAO layers. I have an entry service here. This service layer doesn't do much. It's here in case you want to do more abstraction with stuff. And again, I've shown this before, but there are some good, I'll try to post the links here, but these are good cheat sheets for PostgreSQL as far as entering commands. So that's good to know. So without further ado, let's try to run this main method, and let's see what happens. And I'll also show you the PostgreSQL database. You need to use it in order to engage with this. Okay, it's up and running. I'll quickly show the Postgresql database. We'll try to log in. This, you have to enter your password, enter it. The way you list your databases is you do C or L. Yeah, you click L to list your databases, but then you do this C to go into your database. Try that again. Got a little ahead of myself. You are now connected, and then to view the schemas, I think you do DN, the name of the database. There you go. That shows you all your schemas. We're using a schema called sequences. So we'll list the tables in that database. Let me zoom in on this thing here. Sequences. I chose a word that I have a hard time typing. Okay, so in this schema called sequences, we have two tables. One is called Fibonacci, and the other table is called store sequence. So kind of like you can, this Fibonacci table is like the short-term memory in this program, and the store sequence can store a Fibonacci sequence for a long time. So I'm gonna show you how this all plays out. Okay, so I'm gonna enter. Actually, first let's list the information we got in our databases. So let's say select all from sequences.store sequence. Okay. Okay, so in this table we don't have anything in there, so that's good to know. And in our other table, we'll run that SQL statement. We already have a table that has information in there. This is a Fibonacci series up to 3. So at number 1, the Fibonacci number is 1. At 2, 1. At 3, Fibonacci is 2. So we already got one table up and running. So I got all kinds of features inside this app as far as like user functionality and avoiding errors and stuff like that. So let's say I want to, let's go ahead and generate number 1. Please enter a value. Let's say I entered 1. Let me find the Fibonacci of 1. And right off the bat, it tells me, look, man, the number 1 and the number 0, 0 and 1, those are just base cases. So we're not gonna go through all the tedious work of going through this whole thing with just 0 and 1. So we're gonna try it again, 1, and let's enter a new value. Let's enter a value. So let's try to find the Fibonacci of 10. Enter 10. There you go. It tells us these are our base cases here. The generated value is 55. So if you go, this is the Fibonacci series right here. 1, 2, 3, 4, 5. I like using 5 as the reference point. If you got 5 and 5, then you know your thing is doing good. 8, 13, 21, 55. So now it gives me more choices here. Now if I click number 2, which is called new number set, okay, it's first going to tell us that the last entry we just got was 55. Our last generated result was 55. And let's quickly check our table here. Okay, right. So this is our new table, right? So when you enter a Fibonacci number, this program is done so that it will automatically wipe out this old table values we had and replace it with this. Okay, so our table right now is accurately storing the Fibonacci series. And so yeah, what I'm going to say, so it's asking, would you like to persist this sequence? And let's say yes, let's persist it, and I'll show you what that does. And I'm clicking all kinds of stuff here. 1, sequence stored. So that's good news. So what that means is if I go to my other table called store sequence, So I'll click up. So if I go to my other table, it shows that my other table also has the exact same Fibonacci series. And so what happens is, let's say I exit out of this program. So I can exit by just entering Q or the number 4. Okay, so if I exit the program, let's say I start it back up again. And let's say I want to, now remember, both of these tables here have all these values in it. So let's say I go ahead and I want it to just generate, right? And let's say I wanted to find the Fibonacci of the number 6, let's say. What you'll see here, though, is that if I queue up this table called Fibonacci sequence, right, it's got my new sequence here, 6. It's got the new sequence here. So it wiped out my old. But that doesn't matter, because if I queue up my store sequence table, I still have my data there, right? So my store sequence table will store old Fibonacci numbers I got. And I have a functionality here where I can clean out my storage table. So I click 3 to clear stored sequences. Press any number. This is like confirming. Confirm you want it to delete. Storage cleared. So let me queue up that storage table again. And it's empty now. So I cleared out space. And so now I can enter new stuff. So I hit 2. And remember, I looked up the Fibonacci series of the number, I think 6, right? Right, when I looked up the number Fibonacci series 6, I got the number 8. This is stored inside an array. And it asks, let's say, it asks, would you like to persist this sequence? I say no. Let's say I don't want to. Okay, what all that means, though, is it just simply brings me back to the beginning menu, but it actually cleans out. It cleans out my other table. So my other table is empty now. So I can start from scratch. So I think it's pretty cool, and I'll show you another cool feature it's got. So let's say I get greedy and I really want to find the Fibonacci series of a very big number. Let's say 300. Okay, so I have this all formatted and set up. So it tells us that the Fibonacci value of 300 is this very huge number, 2.2 times. It's scientific notation. It's this huge exponent. And it prints out the array, but I have it set up so that it only prints out like the first 50 elements of the array. And then it tells us check the database to see the rest of the information. So this is all formatted nicely, so you won't have to deal with the program spitting out just massive amounts of numbers. But it is cool, though. If you have a full size array of all these numbers, it really does look like that spiral shape that they talk about with the Fibonacci number. And so I can even check out my database here. This one, right? Right. It's just got all those numbers in there. Enter, 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 enter. And when you're in the matrix here, you can always enter Q, or try that again, Q, right? And Q is, that's the letter to kind of escape out of like all this stuff. So I think that is pretty cool. Yeah, it's definitely formatted pretty cool. Let's say I want to clear out that, well actually no, since it's in my table called Fibonacci.sequence, right? I can always clear this table just by just generating a new Fibonacci array. Let's create a new array. Let's find the Fibonacci of 15. That looks more normal. See, if there's less than 50 elements in the array, it will print out the whole array for you. It tells us the Fibonacci of 15 is 610, which sounds about right. So yeah, all this code is up on GitHub. It's got a lot of stuff. It's got all kinds of stuff regarding loops. It's got the algorithm. It's got the DAO pattern. It's got the number formatting, which is pretty cool. It's a static class you can use in your main method. Number formatter, or number format. So that helps you take a number, a big int. See, that's what this program was using. It was using big int. That's what these numbers in the database are. These are called big ints, and that's even how you create it in your SQL queries. Those are big ints, and but it's good to use this number format so you can at least handle it a little bit better. Yeah, but it's a lot of code, man. It's not the easiest thing in the world to put together, and it's confusing with these kind of loops and stuff and how to get everything situated correctly. But I think it's a pretty cool program. The CRUD methods are really cool. I mean, I got CRUD methods to create both of the tables, delete both the tables, read the tables. So you could do a lot of stuff, and I hope to build out on it, you know. Conceivably, you could have just all kinds of databases storing all kinds of sequences of numbers, and then from there, like, sky's the limit, you know. You could start doing like, I don't know what you call it, cryptography or whatever from there. So yeah, check out the code for the Fibonacci sequence. Look into it about what the Fibonacci sequence is, and look more into data structures, because it's important as far as making a lot of money in software. Just knowing how to do that stuff, it's a valuable skill to have. And please like and subscribe, and happy coding.